Welcome to the second day of our workshop for Stochastic Morphometry that's coupled with our Center for Computational Evolutionary Morphology that we have funding through the So this is our first workshop, inviting several speakers from different areas in terms of data resources, analysis, and kind of biological questions. So today is a bit more focused on the, I would say, analytical side and big data, including, starting with Kim Steenstrup Pedersen, that is a professor at computer science here at KU, and also at the museum, the Danish Natural History Museum, where he's responsible for digital collections. So Kim's going to talk about what they're doing now to I guess collect and store big data. So
yes,
so thanks. Welcome.
Yeah, thanks. Basically, the plan is to give an sort of an overview of the digitization effort we have at the museum, and you can see this as this is us that generates the data that Doc talked about yesterday. That could go into more research. More about that later. I have many hats that I could wear, but here today I'm head of digital collections. Okay, so let's see. I wonder why it didn't switch. Okay. Yeah, what's that? Jeg ved ikke, hvad det er. Anyway, okay, I'll just start with a little bit of info about what this digital collection is about. So basically, this is a new section that was established in August last year, and is part of the museum organization under the research and collection pillar, together with physical collections and the different research sections. We are about 10 staff members now, and we have like various areas. The main parts I'll be talking about today. So this is Disco Prepare. Sorry about the point. Someone had a fun day when they came up with these acronyms. Then also DanBIF, and I'll explain why that's important. And also something called Dan Specify, and I'll briefly mention this ARDA DK or species DK. And then we have some other functions that are not directly related to digitization. Anyway, so my plan is to try to tell a story about what we are doing and what we want to do. So there's some things that we are doing now and future stuff. And then I hope to have enough time to end up with a little bit of a snippet of actual research, where we will use parts of this digital collection for doing some fun stuff. But more about that at the end. Okay, so here is an overview of some of our collections. So we have anything from geology to zoology and paleontology and whatever you want. Okay, so you can see this is a meteorite that's in front of the Geological Museum. We have fossil fish and fossilized insect in amber, and then we have specimens in all kinds of shapes and sizes. Now, we estimate that we have in the order of 14 million specimens at my museum. I think this number is way too low. It's larger. This was done by rough counting. In Denmark, we estimate that there are around 19 million specimens. And just to give you the context, at EU level, the estimate is 1.5 billion specimens. Okay. So this is an attempt at counting physical specimens. Okay, so we want to digitize. Why do we want to do that? Well, first of all, we would like to sort of increase access and so use of the collections. this has like many purposes, but one of the things you could think of is that this ensures that the museum collections actually stay relevant in the future. There's also an aspect of preserving specimens, because if you have to loan out specimens, there's a danger that they destroyed or somehow get damaged during this process. So if we can limit the amount of physical loans by having some surrogates, some digital surrogates, that be good for preserving the actual specimen. When you do digitization, you also want to do this using this buzzword FAIR that Doug also explained last time. So basically, we would like our data to be useful. And so it doesn't really help that we have stored it on some hard disk, let's say Dropbox. Now it's available on the internet, but you cannot really use this for anything. You cannot search in this. You cannot correlate this with other sources. You need to be able to do this. Otherwise, it's just a waste of time. And another thing is that we'd like all the data that we could generate, that this has to be freely available. Open science, open data. Of course, you might have situations where you need to enforce some more restrictions on the use of these specimens. But by default, it should be as open as possible. Now, digitization is performed both at museums, but also by researchers that is not necessarily affiliated with the museum. And some of our specimens and then do some form of digitization. And what we need to do is we need to make sure that we actually sort of gather all of this this data that is generated by various actors out there and preserve this for the future, and also make this public available. Okay. So most of this talk is about how do we do this. Okay, so let's start with some basics. What do we actually know about a specimen? Now, besides having the actual physical specimen, we usually have some physical notes attached to the specimens. Here you see some flies, and you can see that in the background there's actually a species name, and underneath each of the needles there are some additional information about who collected this, where was this collected, and so on. Here's another example from a herbarium sheet. I love this one because it shows the messy part of it. You can see some information about where this was found and when and by whom. And then you can also see here some history. There's a debate going on what is actually the correct determination of this plant on this sheet. Okay, so this is examples of where we have information attached directly to the specimen. But there are also cases where we don't have like a label or something attached to it. And then we might have this in the form of old archival cards. Here's an example. Again, you can see that apparently things get corrected over time. Of course, we have started to construct digital representations of all this information. So this has been databased to some extent. But for instance, this card here comes from a part of the collections that haven't been digitized yet. It is only on these cards. Okay. Now, okay, so this is what we sort of have of additional information with each of the specimens. Now, the way we keep track of this is we use the collection management system. And ideally, we have like people think this is just a database, but ideally, we have a record per physical specimen. And a record can contain various things. It can contain information about what is it, the taxon, also information about who did actually the determination of the specimen. There's also information about the collecting event, when was this collected, where, and so on, and also by whom, and so on. You can have preparation type, storage location, and then important, you can also have various digital representations of the specimen. Say you took a picture of the specimen, and you can attach this as well. Then we have other bookkeeping information about how did this enter the museum, is it on loan or has it been out on loan? Okay. So this is, you had these physical labels, needs to go in there. So that's actually part of the digitization process. Even sounds a little bit boring maybe, but I mean, this is super important. Okay, so the way we handle this, and actually handle this in Denmark, is that we have constructed something we call DanSpecify. And DanSpecify is a consortium of all the Danish natural history museums. You can see them listed here. Actually, we are missing one herbarium collection in Aarhus, but they will be entered to the list soon. DanSpecify, the idea was that we took all of these national collections and joined forces and entered into this thing called Specify Collection Consortium, which basically makes a collection management system called Specify. And since we are founding members, we can actually dictate the future development of this program. On top of this, what we have done is we have created like a set of installation of this Specify for each of the members in the consortium. And my museum is running these. So we actually have the actual servers, and we maintain and make sure that things work for the individual museums. Now, this sounds a little bit weird, centralization is that a good thing? But there is actually some benefit in this, because we're going to use this later to do a national sort of aggregation of information. And that becomes easy because we are all using the same system. And by the way, the servers are in Panum just over there. And we have the root password for them. Okay, so that's one thing on the collection management side. Now I'll just digress a little bit, but this is still important. We also have this thing called Danish Biodiversity Information Facility, or DANBIF. This is the national node or Danish node of GBIF, or Global Biodiversity Information Facility. And our node was established exactly the same year as GBIF was established. We also what is called voting participants. Now, what GBIF does is GBIF collects occurrence information. So someone observed this beetle at this location at some specific time. What you see here on the map is just a visualization of what Denmark has provided into GBIF. You can see we have around 48 million occurrences, so that's an okay amount. We're actually up there compared to a lot of others, probably also because we were some of the first to join in. Now, why is this relevant for digitization of museums? Basically, the way we have constructed this is that DANBIF actually is part of a museum. There's a little bit of IT infrastructure that's actually housed at the Aarhus University, but otherwise it's basically us that are sort of maintaining this national office. But it's open for anyone. Currently we have 2 staff, and the idea is that DANBIF should facilitate that we aggregate, collect biodiversity data and share this via GBIF. Currently, data comes actually from a very broad range, from researchers, from museum collections, also public and private sector, and also citizen scientists, so people running around with a mobile phone taking pictures of birds. DANBIF also has the responsibility of maintaining an authoritative Danish taxon database. So we have that on top. Now, and then we also do work on this which is a new initiative of having a Danish portal of biodiversity in Denmark, which includes also public data like the environmental monitoring agencies and so on. Now, why is this interesting for specimens, well, it actually gives us a direct highway into deep publishing data. Now, let's get down to the actual business here. So our main activity now is this DASCO, or Danish System of Collection. This was initiated last year. And the idea is to build up a national research infrastructure with a focus of like building digitization labs, infrastructure, and also to do digitization at least to some extent. Currently, the DASCO is a consortium of 4 partners that you can see here on the map. DASCO is going to be the Danish hub of this EU initiative called the DISCO, which is Distributed Systems of Scientific Collections. Yeah, all of these acronyms you have to remember them. But basically, this should do the same thing, but just at an EU level, sort of aggregate all museum information that we have and share this. Okay, well, I've already mentioned this. So we'll be building up some labs and some IT infrastructure. And the long-term goal is to say, okay, we have 19 million objects or specimens in Denmark. Let's just digitize all of them. Of course, we can ask, does that really make sense? Maybe not. But at least we should sort of do a big chunk that also makes sense from a research point of view. Sort of just quickly on the financing of DASCO. So the current financing comes from the Danish government, the total budget is 60 million Danish kroner, but the government pays half of it, and the partners had to find the remaining parts of this. This funding can be used for purchasing actual lab equipment, scanners, whatever, and also IT equipment, but also for some salary. And then the co-financing is basically the actual percentages of man hours from the different participating partners and some other bits and pieces. Okay, and of course for DASCO we need to sort of secure funding for the future, because 5 years, that's a nice start, but we need to keep this rolling for the next 20, 30 years. Okay, let's get down to the actual digitization. So this is a pixie drawing of how we envision the digitization pipeline of DASCO. Okay, so of course we would have some actual, say, digitization labs, some stations where you could take pictures of your pinned insects, your butterflies. You could do a CT scan or use a microscope or whatever you need. Okay, so that means that we can go from a physical representation and then have derived products, digital representations of this physical specimen. Okay, so you should remember again that in some cases we have these paper, these notes. Those are important, these labels. So in many cases we would actually also like to actually take pictures of this, because we don't actually always have the data from these transcribed in a digital form. But you can imagine that that this contains various things. It can also be the results of some molecular analysis. We actually also have audio recordings of frogs and birds and so on. So well, a lot of things could go into the digitization lab box. But then the idea is that once we have taken a picture of a butterfly, we need to perform some form of processing of this. This is what I call the specimen data refinery. This could be things like just checking that is the image actually good enough. It's sharp. Can we actually see what we want? But you can also do other things like generating some metadata automatically. You can actually read the labels automatically in some cases. You could do some georeferencing, species identification, and so on. You can also do things like quality checking, or is this specimen damaged? Okay, once this is done, then this gets moved into the data repository, where you can see the specifier. So in the stomach, you will be using our collection management system, the system that is used by all Danish museums. So number one is gets moved from the refinery and into the specifier. We also need some storage for actually storing rough guesses is that this is probably 5 petabytes that we use in 5 years from now. We don't really know, but it will probably take up the space. Last part is this data portal, because it's no fun that we have things stored in our collection management system. Collection management systems are not public. You need to have an account and so on. So we need to be able to share this out of the house. But basically what we actually have in place today is we have Specify running. We actually also have some of this data portal things up and running. We of course have some parts of the digitization lab, but this is some of the things we're working on right now. Okay, so let's look at the portal part. So as it is today, we are automatically publishing anything that is specified and that we allow to be published. We publish this to GBIF. We can only do this with biological things, no rocks and gravel. Hope there's no geologists here. And then we also publish our data in this Danish portal Alpha, and also in the Natural History Museum of Denmark's own collection portal. So this is how it looks now. But of course, in the future, things also need to be available via Disco. No one really knows what that means because it's still in development. But we'll just do whatever is necessary at that point. And then we are also actively looking into other sources. Of course, one of them would be Morphosource. For the geological part, it would also be maybe GeoCase, but other platforms are also an option. We don't want to sort of just dictate things here. We're actually very open to what the people actually use. And this is where we would like to make sure our data is represented in a proper way. Okay, so that was about the platforms. Now back to this, but how do we start on this? Well, we had to start somewhere. So first of all, we need to decide on what do we actually mean when we say we want to digitize a specimen. The minimum requirement is that it at least gets registered in our collection management. We know that this thing exists. But we would also like to include some form of imaging or digital representation of the actual specimen, plus label images. And I write this Tadwig's MITS level 1, which I'll explain on the next slide. This is basically what we start out by aiming for. Now, we also need to make some choices. So concretely, right now we are working on setups for automation of digitization of herbarium sheets, and that's because that's what everybody does. It's super easy, they're flat. The other thing we're doing is we're considering printing text, and that's because we have a lot of them, not just at my museum, but also at the museum in Aarhus. And we are also dabbling a bit with what can you actually do with specimens in alcohol. Can you do some other tricks? That's hard, but it's a fun task. Okay, let me just return to this thing with this MITS level. So, well, okay, so MITS level stands for minimum information about a digital specimen, and it's an attempt at standardizing the terminology around digitization. What do you mean when you digitize? In our case, we say MITS level 1. And that means that things need to be registered in the collection management system, and it also needs to have some form of image of the specimen and labels. And registration can actually be at a minimum level. So it could just be that, oh yeah, we know sort of roughly what this is, roughly that it came from Africa, and nothing more. Right? But at least now we know we have one of these things, and it's from Africa. Okay, but preferably we want to go a little bit deep. Now, yeah, okay, I already said this. And then we are postponing the actual problem of, let's say, transcribing. So this is what would be in this mid-level 2. 3 is like you try to really extend information about this specimen beyond what is on the label. Okay, but we're not saying we will not do this ever, never. But right now, mid-level 1 is the minimum requirement. Okay, so just a few thoughts on the digitization lab. Okay, so since we have been focusing on looked around and actually also done some previous experiments with both digitization of butterflies and of fishes via various companies that claim that they do industrial scale digitization. It sounds fancy, but the price tag is enormous. And then, you know, in the beginning, the other idea was to say, well, why don't we just do our own? But actually, after sort of looking into this in more detail and also looking into what other people have actually observed with this, for instance, what is the actual throughput rate, so on. This does actually not look like a good way to go. There's also problems if you have a big setup, you would need to move settings from different places. So you have this transportation problem where you can risk damage to the specimens during transportation. And then this price tag is just ridiculous. Yeah, okay, so what we are actually looking at now is to say it's much harder to have like one person workstation where you could put the workstation basically in the collection. You do Herbaria sheets right now, and you do Greenland Herbaria. So you put the workstation just besides the shelf with the Greenland Herbaria. And then you just do your thing. So this reduces the need for any form of transportation, and maybe that can sort of counter that maybe you are slightly slower. And actually what we have seen up to now is that it might not actually be much slower than what this industrial scale type of process have been claiming. But anyway, we need to dive more into this. And you can do the same thing for pinned insects, and you can, like with pinned insects, you might want to worry about, do you really want to remove the labels or not? Or can you do imaging of the labels with them on the needle and stuff like that? But anyway, this is some of the problems we're looking into. But then on the side, since we have the DTU 3D Imaging Center as partners in Dashwood, we have access to all kinds of fun scanning equipment. So we can actually do X-ray based CT and MAP-CT scans of things. Surface scans via DTU, also by KU, we have access to Mark IV and ESS. So we have like Syncron time, and whenever the ESS installation up, we have the possibility to use this neutron as well. And you can imagine other things that where we actually might want to buy some equipment just to have this, but this is on a smaller scale than this. The goal, or the current goal, would be Herbaria and pinned insects. Okay, so just a few words on who uses our data. Well, okay, so standard is to say, well, it's researchers, but once you have digital representations, you can also use this for educational purposes because it's digital and you can actually use this in classroom. You can also imagine doing things like having extended museum visits. Then I threw in these like general citizens, decision makers in the industry, because there are things that we cannot imagine right now that you could actually use some of this data for. So let's keep an open mind. And for this to actually work for these users, well, it's important with this thing with the FAIR, right? Findable, accessible, interoperable. It really means that I need to be able to say, I am looking for this specific species of butterflies, and I want all occurrences in Denmark, or all occurrences on Læsø, or things like that. But that actually means that you need to have enough information about the specimen to actually be able to do these kinds of searches. It would also be very cool that you can actually use this with other sources of, for instance, with information coming from other European museums or international museums. So that's basically the thing with the interoperable. And reusable just means that we shouldn't put too many constraints on it. You can only use this for this very specific research purpose. No, data is open and available for you. Yeah, well, okay, that was basically it. So, yeah.
So the idea is the whole thing is open, everything is accessible and available. Is that it?
Yes. And I'm now smiling a bit because there will be situations where this cannot be done. So we will need, let me move down to the last part here, because there is something about sharing policy. Which specimens will we allow that we share? And what kind of information do we actually share about the specimen? Do we want to share information about where we got this from? Maybe not. There are probably some things that are GDPR regulated that we cannot share. We should never share like a formal document that we imported this from country X and then find it. But in principle, the goal is share as much and without breaking.
And so like any museum or any collection that wants to have that, they have to have to use it. You're not just getting the data for you and you can control it, make it available for you.
Yes, that's sort of the spirit of it. I know this is something that will cause some debate, but this is the goal. Well, okay, now we just jumped down. I think that's no, this is perfectly fine. Well, let me just sort of phrase the other part quickly. So we really don't know what the end users would use this for. So we need to make it like as available as possible. And also this thing that which platforms do people actually use to search for specific things? We go there. Right? So it doesn't make sense that we make our own secret platform somewhere. We should share it out in the already existing cases, like for instance, multiple source. Okay, the other thing with the data standards, it doesn't really matter. It's, well, it matters a lot for me, but it's probably not super important for you guys. Anyway, okay, so let me just reveal the sad story thing of affairs now. These numbers are from January this year, and you can see that for my museum, we have only covered around 3% of our total collection. So that is 3% has been put into this specified collection. But there's a lot of things in this story because we have tons of legacy databases that haven't been imported yet. So the actual number can easily become bigger. So too much fuss, except for the hassle of doing the imports. The good part is that anything that hits our collection management system actually goes out. You can see it's not 100%, but it's sort of a fair share of things actually gets out there. And in this case here, it's out to GBIF and this our own portal. But this, well, of course, this will grow in the future. The numbers look more or less the same if we start to do an estimate over all of the Danish collections, 3% there, but over at the Dasco is 4.4. So there's a bit of way going for what we hope for in 5 years, which should be 4 million of the Danish collections. Anyway, we have our work cut out for us. Anyway, so just need to remember. Oh yeah, yes. I still have some time left. Good. Let's just have a snippet of science, or what could you actually use this for. So I have a project together with Alexei Solodovnikov at the museum and my colleague Lars at DICO that we call Fylorama. And this project contains 3 PhD projects. So we have a process project, which takes the traditional phylogenetic approach to looking at specific family of beetles, Staphylinidae. And what process is supposed to do is to do morphometrics plus also use genetic analysis. Then we have Robert's project, which is a little bit on the side, but the original idea was that we would like to be able to take things like insect fossils in amber and then sort of throw them into the pot of the analysis. But once you have something embedded in amber, well, okay, you could go ahead and do a micro-CT scan of them, and you would get like rough surface model of the. But what if you could do reconstructions by, so you're anyway also starting these specimens under light microscope. What if you just took many pictures of this and then did a reconstruction where we sort of virtually remove the effect of the amber? But to do this, unfortunately, you have to sort of invent a new algorithm. So you have to do some 3D reconstruction that takes into account that light that gets bended as it hits the amber. So we need to include refraction in the model. So that's the short story of what Robin is supposed to do. What you're seeing here is just the early attempts at using circuits, the big box in plastic, and then you get like noisy point clouds. Anyway, the last project is Roberto's project, where the idea is actually to try to generate phylogenetic trees or estimate trees from images in these. And this is done in a way where we don't actually use the shape or form of light, but the appearance of the specimen. Okay, so the idea is to take images like this and then let an algorithm figure out a good code or representation of the appearance of this specimen. Okay, so we have these new specimens that have been arranged nicely with legs spread out. We also had some that process that they sort of discarded because they were causing problems. Okay, but so one of the things that we are trying out is that we can construct what's called a decommissioning of encoder, and then do a split of the representations to say that we show the model images of specimens on one side, and then we tell it to do reconstructions of this. That's what you have on the decoder side. But along the way, it's try to do a split of things so that it has information that has to do with species and information that has to do with specimens. So you have in specimen, you have the variation within one, which we think is irrelevant for our purpose. Okay, so the nitty-gritty details of this, well, I'll leave that for Roberta to cover at a later stage. I think you're talking about this tomorrow. Yeah. Anyway, so what we then do is, well, for this to actually work, we cannot do this without having some knowledge of the actual specimens we use for this purpose. So we start out with what we call a training set, where we need to know which species and so on is in this. Then we can train up the model so it actually does a split. And what you see at the top is that's the color coding of for each color is different actual species. And this is how the models try to extract things. So it basically gives us a way to do comparison by comparing these points in this high dimensional space. We basically learn a metric for doing this appearance-based comparison. And with this, then we've done some experiments where we try to generate trees simply by grouping things together. So this is close and this is far away, so the close ones that belong together. Okay. And you can definitely do this much smarter, but it actually gives an indication that that we can actually construct a meaningful tree out of this, so a meaningful grouping of the actual species. Now, so going back to the digitization at scale, so for this to work, we need data. In this case, we need a lot of images of actual people specimens. We have in the order of 19,000 distributed in like roughly 200 different species. And for this case, the 200 species, it actually works quite nice. Of course, there's some situations where it doesn't really work. But the next question would be, okay, can we scale this up? Can we like look at a large, whatever we would like to produce? We go to like 2,000 species. Another thing is that for this, you actually need to have many examples of the individual. So it's no good if you only have that one type. Then you probably want to sort of do any other things anyway. But in our case, we had around 200 species of the species things that we worked on. We also had examples where we had a few and then it didn't work. Another sort of side problem with this is that of course the quality of the species are super important. The model actually learns to see some minute details on the individual beetles, and if these details are simply not there because the resolution was too low, then well, then the flaws again. Okay, so there's various like things we want to try out in the future, and so one of the major issues is actually that in this this collection of species, there are some species that you can only tell apart. Genitalia or sequencing or barcoding or something like that. And those we cannot really handle. We can only do as what you can do with the visual file. Okay. And that's basically what I had. Thank you for your attention.
Yes. You mentioned registering databases. Many of those also we do.
Yeah.
For example, so I know many of the museums actually are in the.
Yes.
How do you plan to try and back up that data? The really digitized data or simply be decided?
No. We don't discuss stuff. But so for instance, we are in the process of actually pensioning some of the older data sets by sort of, not deleting them, but you can do some tricks in debrief where you sort of keep the linkage, but now it will point into a new dynamically update. So the issue is that yes, at least in some cases, there will probably be some cases that we cannot. And you could say that there is also this possibility of harvesting some information back. GBIF is one place, but there's other places where we do that. But we just need to be a bit careful. We definitely need the curator of the collection to actually look into the results before we accept this. But yeah, but this is one of our headaches, this thing.
Here, 90,000 specimens with equal representations. Do you all have any like I'm curious how many of those are 2D images versus CT scans or what do you think?
Oh, well, actually, no, I don't have a, but I think most of this is actually 2D.
Right.
But we also have 3D.
Right.
And unfortunately, a lot of that is hidden away on some hard disk and is not available yet in Specimen. Or well, not in the way it's with you guys. In Open source.